This is a very interesting question. Two particles are projected from a point at the same time instant with the velocities whose horizontal and vertical components are u1 v1 and u2 v2 respectively. Prove that the interval between their passing through the other common point of their path is given by 2 multiplied by u1 v1 u2 minus v2 u1 divided by g times u1 plus u2. So first let us draw the basic. This is, let us suppose, x-axis and y-axis, and two particles we are going to consider. Let us consider this is particle A, and it strikes at this point, and let us consider another particle, and that is particle B, and it strikes the common point. This is particle B, and the common point is given as P, and this is the vertical distance of both the particles. Let us call this point as M, and this is the initial coordinate O. So in this case, it is given that the horizontal and vertical component of both the particles is given as u1 v1 and u2 v2. So let us suppose the time taken by particle A, time taken from O to P by particle A is t1, and by particle B is t2. And it is also given that the component of the velocity, horizontal as well as vertical, of particle A, so we can write it here as horizontal component of particle A is given as u1, and vertical component of A is given as v1. Similarly, the horizontal component of B is given as u2, and vertical component of B is given as v2. So the horizontal distance traveled by by particle A in time t1 is OM, and which is given as the horizontal velocity, that is u1 multiplied by t1. It means OM is equal to this. And similarly, by particle B in time t2 is also OM, so it means OM is given as u2 times t2, So from these two we can say that OM is equal to OM, left side are equal. So U1 T1 is equal to U2 T2, and let us call this as equation number 1. One equation. Now we find out what will the vertical distance. So vertical distance for particle A, in time t1 will equal to pm, which will be equal to pm will be equal to v1 t1 minus half g t1 square, and for particle B in T2 will be also equal to PM. So we can write PM is equal to V2 T2 minus half G T2 square. So in this case also the left side are equal. So we can equate right sides, and it can be written as V1 T1 minus half G T1 square is equal to V2 T2 minus half G T2 square, and let us call this as equation number 2. Equation number 2. And from equation 1, we can write V1 divided by U2 is equal to T2 divided by T1. So from here we can find out what is the value of T2. So T2 will be equal to U1 U2 multiplied by T1. Let us call this as equation number 3. And in this equation, let us add 1 both sides. So we get this as V1 U2 plus 1 is equal to T2 T1 plus 1. So we can write it as U1 plus U2 divided by U2 is equal to T2 plus T1 divided by T1, and from here we can find out what will be our T2 plus T1 is equal to U1 plus U2 divided by U2 multiplied by T1, and let us call this as equation number 3. Equation number 3. So from equation 2, we get T1 square minus T2 square is equal to 2 upon G V1 T1 minus V2 T2. If you open the bracket, open this square of left side, this can be written as T1 minus T2 multiplied by T1 plus T2 is equal to 2 upon G V1 T1 minus V2 t2. And we already know the t1 plus t2. So substituting here t1 plus t2, so the t1 minus t2 and t1 plus t2 is equal to u1 plus u2 divided by u2 multiplied by t1 is equal to 2 upon g v1 t1, and we already know the value of t2, that was equal to u1 u2 multiplied by t1. So if we take t1 common from the entire equation, so this cancels out. So we will be left with t1 minus t2 u1 plus u2 divided by u2 is equal to 2 upon g. Taking LCM, v1 u2 minus u2 u1 divided by u2 and u2 cancel, so we get this as time difference t1 minus t2 is equal to 2 upon g v1 u2 minus u2 u1 divided by u1 plus u2, and this was the question to find out what will the time difference. So we have to prove it. Thank you.